wonderful night to be here with you, ladies and gentlemen. Thank you for joining me on our next lesson on inequalities, lesson 4.2. 4.2 from page 132 in your Big Ideas book, where we are going to apply what we learned. You know what we're going to do. We're going to solve addition and subtraction inequalities. Now, I'm just going to give you a heads up. I'm just going to spill the beans. I'm going to tell the secret. Addition and subtraction inequalities are nothing more than addition and subtraction equations, with one exception. We've taken the equal sign out and we put one of those four inequality symbols in. And they're solved exactly the same way. We want to isolate that variable. We want to put it on one side or the other of the inequality all by itself. And we want to do it using properties of equality, because whatever we do to one side, we're going to do to the other. So we're going to use inverse operations to isolate that variable. And now we're going to use properties of inequality. Because we're not keeping the equation balanced, we're going to keep the equation true. And so you've taken some notes. You've taken some notes from the top of page 132. And they basically said, excuse me. Holy smokers, got something caught. Here we go. It basically said that when you add the same number to each side of an inequality, that the inequality will remain true. That's what we're trying to do. So properties of inequality keep the inequality true. That's all it does. So looking at it numerically, we have, and you all know this, 5 is greater than 1. Well, if I add 6 to both sides of that, I would say that 11 is greater than 7. That is a true statement. It would work no matter what direction that inequality went, as long as we have a true statement. And looking at it algebraically, all they're saying is I've got this number. Let's say A is less than B. And I add C to both sides of that inequality. That we would end up with A plus C is less than B plus C. So as long as you start with a true statement, then whatever you add to each side of that inequality, you will still have a true statement. By isolating the variable using inverse operations and keeping the inequality true by using properties of inequality. All this is done exactly the same way as we did equations. All right, so let's just get down and get it done. The first one, x minus 2 is greater than or equal to negative 4. So to isolate that variable, I am going to do the inverse, which is to add 2 to negative 2. That makes 0. So now I have x. If I use properties of equality and add the same 2 to both sides, I know that inequality symbol is going to stay true. And then when I take negative 4 and add 2, I get negative 2. So I know that my variable has to be greater than or equal to negative 2 for that inequality to be true. So now I'm going to graph. We're going to solve, then we're going to graph. We learned how to graph in our previous lesson. So I take my target number, I put it in the center, and then I need one that's greater and one that's less. And you know me, I like to use the very next number. So the number that's greater than negative 2 is negative 1, and the one that's less is negative 3. Also, when we learned how to graph, you know me, I like to graph my target number, and I like to graph above the number line. If you want to put it right on the number line, you can. I recognize that I'm greater than or equal to, so I need a solid filled in circle to say that negative 2 is part of the solution. And then I recognize that my variable is on the left. It's the first number listed in our inequality. So I know from what I've learned that the answer, the arrow that shows all of the numbers in the solution set, will follow the direction of that inequality symbol. That only works when that variable is on the left of the inequality. In other words, the first number. And I can prove that. Anytime I have any doubts, you can always conduct a test. Now, I'm going to do the test twice. The first time I'm going to do it, I'm going to grab a number that says it better be true. In other words, following the arrow. So I'm going to come over here. I know the number 4 is in this direction of the arrow, saying that 4 is a part of the solution set. So if I substitute a 4 into my inequality, x minus 2 is greater than or equal to negative 4. If I substitute a 4 in there and say 4 minus 2 is greater than or equal to negative 4, I better have a true statement. And 4 minus 2, that's right. That's 2. And we're saying that 2 is greater than or equal to negative 4. And of course, that is also true. So that means we graphed the correct direction. Well, what if I didn't use a number that I believe to be true? What if I used a different number? What if I used a number on the other side, like negative 4? And I come over here, I have x minus 2 is greater than or equal to negative 4. Now I picked a number that, according to my graph, better give me an answer that's false. Otherwise, I didn't do it right. So I can put a negative 4 in there. Negative 4 minus 2 greater than or equal to negative 4. Well, negative 6 greater than or equal to negative 4. We know that that is not true. That is false. That is a false statement. We expected it to be false because that's what our graph said it would be. So you can always conduct a test anytime you need to. Ladies and gentlemen, our next example, number 2. Y minus 6 is less than negative 7. To isolate my variable, I am going to add 6 to the variable to get that to be 0. So now y, I know I'm going to keep my inequality true because I'm going to use properties of inequality to add that 6 to both sides. And negative 7 plus 6 gives me negative 1. So now I'm going to graph it. Negative 1 is my target number. 0 is the next number greater, and negative 2 is the next number that is smaller. I am going to use an open circle because an open circle says that negative 1 is not included in my solution set. My variable is on the left, so I can follow the inequality symbol, and I can graph all of the numbers that are in the solution set by drawing my arrow to the left. And of course, if I wasn't sure, I could go back and conduct a test. Example number 3. Negative 1/2 is less than or equal to x minus 1/4. Now I'm looking here and I'm saying I'm subtracting 1/4. So to do the inverse, I'm going to add 1/4. That would give me x. My inequality symbol stays true because I'm going to use properties of equality, and I'm going to add 1/4 to the other side. And I know that negative 1/2 plus 1/4 is going to give me a negative 1/4. I can work that out for you. Negative 1/2 plus 1/4, changing this to fourths. And I would say that this is 2/4. A negative 2/4 plus 1/2 would give me a negative 1/4. So my inequality says that negative 1/4 is less than or equal to x. I got my target number, negative 1/4. What is greater than that? I'm going to go with 0. What's less than that? Negative 1/2. I'm going by fourths. Okay, I could use whole numbers. I could put a negative 1 over here. Whatever you want, as long as you make your number line correct. And now I know that I need a closed circle because my target number is included when it's less than or equal to negative 1/4, less than or equal to my variable. Now, here's where we got a problem. Is that variable on the left? No. So if we follow that inequality symbol and we draw it in that direction with my variable on the left, I know my answer will be false, and I can prove it. If I take one of those numbers, let's just take the one we have right there, negative 1/2. Make it easy. I have negative 1/2 is less than or equal to x minus 1/4. Well, if I put a negative 1/2 in there and say negative 1/2 is less than or equal to a negative 1/2 minus 1/4, well, I would get negative 1/2 is less than or equal to a negative 3/4. I already know that a negative 1/2 is in fact greater than 3/4, a negative 3/4. So I cannot do that when my variable is on the right. So I have choices. I can either rewrite this. We learned that I can rewrite this inequality statement by flipping it and saying that x is greater than or equal to a negative 1/4. All I'm doing is reversing the order of everything that's there. That means reversing the inequality symbol. Now with it on the left, I can graph to the right, and we know that's going to be true because we already proved that negative 1/2 is not in the solution set. Well, ladies and gentlemen, our last example of the night, of this lesson. B minus 3.8 is greater than 1.7. So I'm going to add 3 8/10. Doing my inverse operations, I'm going to add 3 8/10 to the negative 3 8/10 to get 0, leaving me with B greater than, I know it's going to stay true because I'm going to add the 3 8/10 to both sides, and I would get 5.5. My target number, 5.5. I have 5.6 is greater, 5.4 is less. I know I'm going to have an open circle on my target, an open circle on my target number. I was saying it and not doing it. Open circle because it is not included in the solution, and since my variable is on the left, I can graph to the right and follow the inequality symbol. Ladies and gentlemen, here's your quick writes. Go ahead and write those two down. You're going to make your own graph. Once again, just draw a graph on your paper. You just need 3 numbers. Write down m plus 2 is less than or equal to negative 4, and x plus 3 is greater than negative 1. Solve both of those. Take a quick break. Come back and join me. We do have 2 more videos tonight. See you in a few.